We're here in our podcast series providing value for architects and designers and build professionals who are seeking to utilize industrial hemp in their designs when they're answering the questions about sustainable and healthy builds. And we're happy to be on our journey and have some of the professional engagement from Mark Benjamin. For those of you who've gone through other programs that we have, Mark will be a familiar face to you, and he's got a lot of value from the projects that he has done in the past. And we're going to bring that value to your projects so that you can have a successful go at it in bringing Hempcrete and building with hemp to your projects. Mark, you want to give us a quick introduction, and then we can get on with what we're going to be going through today.
Well, I'm Mark Benjamin, structural engineer licensed in Colorado, Wyoming, and New Mexico right now. My company, Crown Jade Design and Engineering, was started by my third son, David, and myself in 2004. And we've been working on a lot of interesting projects. My very early interest has been in sustainable construction and living. I took CSU engineering science to do solar engineering in 1976. But after 2 years, I had a growing family and decided to go to work. Karma always comes around, we'll hear later. I built my own log home up in the land in Montana, then moved to Michigan and worked in solar heating installation, insulation, retrofits, then construction management. In 1989, I had a job injury. After 2 years, I got a settlement and went to AU, Northern Arizona University in Flagstaff. It was much cheaper than trying to get to CSU. I bought a house and became a resident. Got my bachelor's in civil engineering there, moved right back to Colorado, but still worked in construction management. Finally took my test and got my PE in 2004, and that's when I started the company.
So it sounds like there's always been the construction, either the design or the build phase of things, and it's really captured the spirit along the way. And then, as far as the sustainability and the healthiness of the built space, it sounds like there's some passions that have run through that thread. Tell us your origin story and how you got into the hemp field specifically, because I know that's one of the very key components of how people came into this space that will resonate with a lot of the architects and the folks that are looking to design their own homes that will find this. There's a lot of different pathways to find building with hemp. What was yours?
Well, I had worked in timber frame engineering, straw bale engineering. I'm an early member of strawbale.org. I've done rammed earth tires, earthship type homes, and I was approached by some hemp builders in Loveland here in Colorado. There was a client they had whose house had burned down in the 2013 High Park fire. Lost 250 homes in that fire. It was quickly eclipsed by another one down south that lost 350 homes. But this person wanted to use logs from the land, and so I was very familiar with log engineering, mostly as posts and beams, and then do a hemp hand pack infill. So that was 2014. That was my first hemp project.
And so now, one of the things that I think is very valuable for a design professional to unpack, and I really love the fact that you can be part of the design as well as the engineering. And so there's the creative and the execution phase that really comes together nice. And we're going to enjoy learning from some of the wisdom along there. Unpack as you see fit the that engagement with the client, and then at what point did a builder come in? Did they already have a builder, or were they just pulling the puzzle pieces together, or is this one where they were a self builder?
It was Josh and Melissa Rabe. I'm not sure how much their involvement is in the community anymore, but they're the ones that contacted me and then introduced me to the client, and I worked directly for him. They had some ideas of how they wanted the design. It has a clear story type roof facing south. I didn't think to pull up his plans. They were pretty basic back then. I think mostly we only did structural for that job. So yeah, we worked all together, the hemp builder, the homeowner, and us as the structural engineer. Now, part of my logo is engineered for the way you build. So that's what we try to do is work with the builders.
Now, what are some of those key components to facilitate that? Because I'm very adamant about encouraging people to bring those meeting of the minds together early on. What are some of the things that you like to see from a builder and a client, and then how did this take place on these projects you've got?
I like if we're going to be doing the drafting, so we are a drafting service as opposed to an architect. So we need a layout. It can be simple from somebody. It's good if we can participate in some of that layout. I had a client years ago who was insistent on having a hallway down the middle of his house with a ridge beam. So we had to do a whole bunch of transfer beams to get that load down to ground because he had his plan. So if we can point out things like, do you really want a 36-foot long ridge beam? You can cut the size of that in a quarter by putting a post in the middle next to your kitchen island, for instance. So we like to get involved in those sort of things.
Some of the things that might be beautiful and lovely and what you would pick out on your Pinterest page, but it doesn't always make sense on practical application. Make a little bit more distinction about the drafting so people don't come to you with, hey, I've got an idea, and then it has to be that ideation phase needs to take place. They already know what they want and can get you a good sketch. Is that correct?
Yes, typically, and then David Milburn yesterday verified this when he talked about the Strauss residence. The architect will do a bubble diagram. Different bubbles represent different functions, and then he kind of turns them into rectangles and then works on his vision for how it's going to look. Like David mentioned, putting a curved roof on that house. We need somebody to come to us with that already in place. It can be a simple sketch, but that's how we start out doing drafting. Along the way, we help them with structural decisions like I talked about earlier.
And then when that builder, did y'all engage with them any at all? Had they done Hempcrete houses before, or was this kind of their intro into that space?
I believe the Rabes had worked on some projects in the past, but this owner, that was, of course, his first and last foray into that. I believe he rents the space out now for music people, art people, things like that.
And so a lot of times it'll be a one and done where somebody is going to build something for their own use, whether it's a home or a Airbnb or a specific venue, and then they encounter all that heartache, and then the end of that body of knowledge. And so it is very important to listen to the heartache and the pain points of others who have built before you with the methodology that you're using. And so I'll let you take it from here on some things that you would like to show and tell along from the process. And then all I'll do is just jump in with a few questions as they come to me about a little bit more detail on a specific phase or maybe how that interaction took place.
I do have a photo of that project that I can share right now.
It darkens out a
Okay,
little bit.
so this is one shot of this lovely cabin in the mountains outside of Loveland, and you can see those logs that Mark was talking about. They really make a huge difference. I have other shots of this, but I'll just save this one so we can pop it in while he's talking later on.
The challenge with this one is the log braces that we put in to give this thing lateral stability, even though the hemp is a redundant system, which I'll talk about later. Trying to hand pack around that stuff and then put the stucco up against the log, they don't know if they would do that again. But it is very beautiful and unique now that it's done.
And those are the tidbit those things that you talked about are thousands of dollars worth of value, to an execution, and so, did they come into the project wanting the exposed beams on the outside?
They just have these big logs and they knew they were bigger than the wall.
Yeah, and so did those carry on through, and are those revealed on the inside as well?
Yes.
Oh, it's nice. And then, did they consult with a plaster contractor or a subcontractor before, coming through and initiating the build?
I believe they did most of this themselves. They might have had some professional help. I can't remember anymore.
Because having the plaster dye into the logs like that or into the windows as well, it's a lovely detail, and then I didn't know if that was part of the, drafting phase that y'all brought to bear.
Uh, Not really. I think we just did the structural plans in this
Yeah.
one. They had sketches.
And so that's another thing that if you're, an individual building for your own, you can make those decisions later on and then, at the project level, as long as the framework and the structure is properly engineered and you are coloring within the lines, you don't have to color the whole thing. You can make some of those decisions, in the field as long as everything else is what it needs to be, and so
To talk about some of the stuff in my outline here. All natural wall systems are considered infill other than load-bearing straw bale walls, which are really not accepted in Colorado. There will be some sort of a separate structural system. It'll be a centered or post and beam or even an exoskeleton system, as we saw partially there in that last project. Now, having spent a lifetime in construction, I really know how houses go together, and that a house typically, except in a hurricane or a tornado, do not roll down the street, tip over, or fold up like a house of cards. The shear systems that we now have to incorporate into buildings are really more than what is needed, but I don't cut corners. I still try to follow the code. Engineers that plug their projects into a black box software has an output that says, okay, this is what it's going to do, and this is what we have to do to resist it. In the past, I never used to put giant hold downs, a million nails in a sheet of plywood, straps for everything. At most, there was a piece of plywood on the corner of the building and then fiberboard in between. Well, I just say all this to simply highlight the letter of the law code approval that's in place for new IRC construction. So going back to natural building, if a structural system is designed to resist all those loads and forces, like lateral force from wind, then to me, the infill is a redundant system. As an example, Hempcrete, hemp blocks, they all have compressive values listed in their testing. For example, a French cured hempcrete that I have data for has a compressive strength of 87 to 100 psi. That converts to 13,000 to 15,000 psf, pounds per square foot. So to determine the shear value of it, which is pounds per linear foot, you multiply that number times 1 foot, which is typically the thickness of a wall, you have a system that has 13,000 to 15,000 pounds per linear foot shear value. The strongest wood-framed maximum shear value, depending on nail size and spacing, plywood thickness, all that stuff, is 2,045 PLF. So when I say I consider infill to be a redundant system, the numbers are there.
It's almost to where it can be the system in and of itself once we have more data and testing and all of that, to where the industry catches up and all of those values can be known more accurately. But I really love how you point out taking one value and translating it through extrapolation to another value.
Yes, I have one client. I've redesigned his foundation for him because it was ridiculous. And he's got that built now, but he already has snow. So over the winter, we're going to redesign his structural system because he had 4-inch steel tubes, 4 foot on center, all the way up through 2 floors with a 16-inch glue lam on top. He has a over 100 PSF snow load, but a 16-inch glue lam at a 4-foot maximum span? No, we're going to use some of these compressive values that I talked about. He's got a good hemp block product, and we're going to redesign this thing so it's affordable.
Now, are you taking them through the lab testing or process, or are you just using what the manufacturer comes out on their data specs?
We're not big enough to provide for, pay for any kind of lab testing. I'm not involved with any testing agencies. I am a member of ASTM, so anytime a code official quotes a standard, I'm able to look it up and either use it to support my viewpoint or something.
But the important thing for folks who are looking at specifying this is that they can think some of those thoughts. And it's not just a blind process where you have to go through it. There is some of that ideation and the incubation of thought to where you do think things and then can put those into a design scenario that, like you mentioned, is supported. And I do know the manufacturers are coming out with those to where they measure according to what's accepted through scenarios such as the ASTM, and then you do know those values. And those are the important questions to ask, like where did that value come from? Is that a lab verified thing and an assumption that you can run with, or is that just something that they came up with on their own? And those are the questions that the professionals already know to ask, but they can ask them specifically to this material. Are there any other scenarios like that come to mind?
I know we heard a presentation yesterday about the rammed earth blocks, and this particular designer had concern about the blocks have a certain compressive strength, but to use it as a shear value, how they're connected together. So we do look at how things go together now with a hand-packed hemp wall with that kind of compressive strength that I was talking about. It's good to have some sort of a frame in there that'll resist some shear, but not overboard.
Right. And then I love the mention of how things come together because there are several different methods of doing that. And there's 4 unique ones that are in the IRC, that Appendix BL. And those can be represented a couple of ways. But then there's block scenarios, panel scenarios, mechanical installation scenarios. Are the studs and the supporting framing members interior, exterior, encapsulated, so on and so on. And so all of those need to come into consideration on how it's all fastened together. That's an excellent point. Were most of the projects that you had cast in place method, I believe?
Most of the early ones that were built have been cast in place. I have some block projects that we've already designed. I just learned yesterday that a hand pack good sized project is going to be converted to block. So we're going to have to change some details on that and possibly the structural system. I know there are blocks that have stud spacing locations that we can use. So I will be looking at all that once I get the brand of block from that client.
Well, these are great conversation points. I'll let you keep walking us through your process and then we'll pick them out as we go.
Well, regarding the health of a person, the safety, I'm also a passive house consultant, and that main goal is to create an airtight, super insulated home. Now, I've known a lot of clients and a lot of builders who, pardon my French, want to do a half-assed house. If they fall short and it's not airtight, then where that little hole is, and I've seen passive house testing where the corners are not tight. And so that's where all the test smoke just pours out of. Well, all the moist air in the house is going to rush out those small holes, condense, and rot the house. Well, with a natural built home, you have breathable walls. You've got a complete infill insulation blanket surrounding the interior. The material's not rottable. I've stayed in some Hempcrete homes up in Steamboat. They're quiet, they're comfortable, they're relaxing. Now, in a typical home built to code, which has been called the worst house you can build and not break the law, the wall and floor coverings that are currently being used and have been, they can be very toxic. I've got clients with toxicity issues who can't even have OSB or fiberglass insulation covered up by other materials in their homes. So this is going to be very healthy construction. It is.
There's a lot of people who have those hypersensitivities, and then I think there's a slew more that have them that don't know that they do and are just grinding it out on a daily basis. And so I like what you mentioned. the the code is the worst possible house you can build without breaking the law, and then we can go up from there. That's a good quote. And then now talk more about the health considerations and that phase of engagement in the client conversation. And so there's a new client who's brought a health concern. Either they have an illness or something or some sort of ailment that they're bringing to your attention, or it's just simply a priority for them. How do you go about that? And what are some of the key talking points that translate into a design?
Well, for us to be able to do that kind of a design, we do need an educated client. I have a current job that we just signed up that it's going to be an insulated concrete farmhouse, and their client has a lot of toxicity issues. So the builder and the architect are really working with that client. They're bringing them samples of everything that they're going to put in the house and make sure that this lady isn't affected by it. Architects are better suited for that sort of interaction. We will draw what the people want us to draw. So if we have an educated client who says, no, I really can't have any OSB, maybe some CDX plywood, or what kind of insulation that they want to put in the walls. So we produce a permit set of plans. So they don't have material lists and room finishes and all that. It's a basic set of plans to get a permit and structurally build it, because we have all the members and all the connections and everything in our plans. It's the homeowner builder or the homeowner working with the builder who helps to specify that sort of material as they go.
So keep going down the pathway. You mentioned where people were able to be educated and become educated, and I know there's a lot of biohacking. There's a lot of health and wellness. Health and wellness is related to real estate. That's a very popular topic. How are you seeing some of the best ways to engage that to where it doesn't become noise and confusion to the client?
Again, those clients need to know, the ones that come to us just to have their plans drafted. Architects are very important in that sort of realm because they'll spend the time with those clients. Again, we will draft what people want us to, and we don't put a lot of detail. Like architects will have pages of manufactured window details and everything for the layout of the tile in the master bath. So
So what I'm hearing is that's one of the main important roles of the architect is on all of the health and wellness engagement. What the engineer is going to do is engineer something that is not going to fall or have any sort of negative impact that way. That's not going to have any sort of bad thing happen. And it's up to the architect. And that's one of the roles that they do is that education and that engagement to where at the end of the day, both the architect and the engineer have an informed client. But that's one of the main roles that an architect will play.
Yes. Ideally, with an architect working with a client, we could produce those construction drawings. The architect would input their details, their material list, finish schedules, but we can do the floor plans, elevation sections. We do it in 3D, so there's a nice 3D view on the cover, and then do all the structure. So more of a back office. We could work with architects in that way.
And so when everybody's looking to carve out this niche, and I think it's a very popular niche, and I know it's one of the motivations for being healthy and being sustainable are that driving motivator for much of what society is doing because we've had these large trends like COVID where we stayed in our houses a large portion of the time, more so than normal. Now we really feel the impacts of that, and we want to present that value into a built space moving forward. What are some of the other big motivating factors that you're seeing that you translate back and forth from the designer, the builder, and your role as the engineer?
One of the things that I like to talk about is, sustainable construction. It has been said that if wood framing was introduced right now into our code as an alternative material, it wouldn't be allowed. The material properties all over the board, even the connections can damage the material. A lag screw in the wrong place will just split it, and it burns like crazy. So, yeah, there's a million pieces of wood in a home, and each one has a nail. So, yeah, the wood from those homes comes from our forests, which are sanctuaries of peace, harmony, and many of the living creatures on Earth. Now, hemp products are a waste product, fast growing, so natural building systems help sequester the excess of carbon in our environment.
So there's the carbon sequestering and there's the reduction of forestry products. And then even if you're still using forestry products, for example, you can take out a lot of the sheathing and then the hemp provides that either limited shear values where you can do it with simple bracing instead of using the entire sheet of sheathing on there or minimizing the studs. I know we've got some colleagues that do more advanced framing or greatly reducing the amount of timber that goes into it. Are there any other material selections that you've seen that are positive that work along with the Hempcrete?
They pretty much are. In the past, I've done straw bale projects where it has a steel frame, and we actually set the steel diagonally in the wall, so it's much easier to cut out to have the bales touch each other. With the hemp blocks, they have those openings cast into them, or you can fairly easily cut those openings for some kind of a structural member in there. And I would think even if you're hand cutting these openings, it'd be easier to have a diagonal post, whether wood or steel, in order to just have to cut a little V out of your block instead of a big rectangle.
So how these things come together, there's a lot of good cooks in the kitchen that are coming up with those ideas, and to incorporate with the presence of an engineer is always of value when coming up with good ideas. We'll let you keep moving on in your process and then keep jumping in with questions.
Okay. Under construction and cost consideration, imagine handling each of the million pieces of wood in a typical home. And that usually always happens on site in any kind of weather with varying degrees of experienced craftsmanship. A natural home, especially if it's a more modular version, panels, hemp blocks, straw bale, those walls can go up fairly quickly. And if you get that with a straw bale, you have to get at least your skim coat on the outside. It's weathered in, and then you can work on things on the inside. Now, unfortunately, until this becomes more mainstream, the construction of natural built homes will either be a labor of love or a possible higher cost of a specialized contractor.
Are there any key points or practices or advances that you're seeing to help that along the way that you like to advise on the projects you're a consultant for?
Well, I'm excited about the block projects because they will stack up fairly quickly. And once they're stacked up, you're weathered in. With them coming out of Italy, it'd be good if we had something locally. I was talking to a client several years ago who wanted to convert an old dairy here in Greeley into a hemp processing facility, hemp products, possibly even hemp blocks. But that never happened. It was a big facility and would have been very interesting to get involved in that.
I think the more that we advance, the more the looks will be given. And then when the more looks are given, all the puzzle pieces are going to come together correctly when the timing is right. And I like these projects being the good illustrator of what can be. And even if it's imported for early adoption, then we know how we can produce it here. And I do enjoy seeing the progress in the supply chain on the farm and the processing levels. There's a lot of good advancement there that'll help feed the cooks in the kitchen for the ideas that are going to come out of there. And so you've seen the block. Talk a little bit more about that and some of the advantages that you like, or wherever else you'd like to go on the next phases of the project.
Well, the blocks that I've seen have, well published material properties. And so I'm able to definitely use those for things like the compressive strength converting to shear value, the way that they can be designed to fit around the structural system. I don't know that they're up to load bearing capacity yet. So we do put some kind of a structural system in there. I have a project that had a lot of interesting roof framing going on, and I could share that a moment.
Yeah.
Miller. We just did the structural plans on this job, but the things to point out are they had some large overhangs all the way around, especially out here on these corners of the house. So we had cantilevered microlamps that went out, and then the post was back in here, and this was a hemp. Right here we have a 6 2x4 post, and this is a hemp block project. These walls that don't have any posts in them, this particular product can stack pretty tall without any support against lateral wind forces. So if you consider that there's a wall in between here and all these areas, all this block will just hold itself up. And we have this independent roof system with the post that I showed you supporting it all.
So that would stand just on its own, and then the self-supporting block fills the gap in the middle.
Yes.
Nice.
Yep. So I didn't have to worry about doing a lot of braces between the posts and the beams because I knew the block would provide the lateral stability.
Well, I'll let you keep going through the outline that you've got. I think it's given us some good food for conversation.
Okay.
I might add that I have photos of Aaliyah's house and also a photo of the Andrea's house in Loveland If
Okay.
you want to talk about those projects, I can share those photos as well.
Yeah, I didn't do Andrea's house in my folder. I didn't think about that. We could do Aaliyah's. I have her architectural plans, and then I had those structural plans opened up earlier that I could try to share.
That might be good to unpack a little bit more of the engagement between the architect and the engineer. One of your strongest values is helping people become familiar with that process.
Okay. Well, here are the architectural plans. She had some pretty tall windows here, pretty big windows and a tall wall. Behind this area is a loft, long sloping roofs, the floor plan. Here's that big window. There's a hemp wall separating even at the interior in these areas. And then there was this loft up here. Then she also had a little ADU with a greenhouse out front. So our structural system, a slab, we had some point loads coming down various places. And then the foundation in this area, I think, was a lowered cellar, root cellar type thing. No, thought we had a framing section for the front wall. No, but here's the hemp wall. Is a 2x6 at 24 in the center of this thing, and posts to hold up those headers. Here's our typical bracing, which is cut in 1x4s. This big window had a 16-inch full-length header, so we did this as a code portal frame.
And so you're using familiar tools in the toolbox. These are not unfamiliar things. You just need to know which tool to reach for to accommodate these things. And then, you mentioned the weight. How did you go about the weight calculation on those for the foundation when you were doing those point loads and especially around the exterior beams?
Well, with the foundation, we were pretty deep. I think we had a 48-inch tall foundation wall here. So if we put a point load on this, I spread that out 45 degrees through the concrete and then put it on the footing. And so part of my weight for determining a footing is the point load spread out along with the wall loads and the roof loads and floor loads, whatever else is sitting, and the self weight of that foundation. And then that's how we determine the footing size. Now we had some posts like this one right here. It can bear directly on the slab because we had a 2,000-pound soil. So a 4-inch square, go 45 degrees to a 4-inch slab, you're sitting on a 12 inches of soil. So we can hold 2,000-pound point load on a slab without adding anything. Over here, due to a wall that we had inside, we included a thickened slab. And then we built in a couple of point loads here. I think the footings were all pretty much 16-inch all the way around on this project.
So
Which
the
is
real
minimum size you want is a 16-inch footing, because if a concrete guy uses the old plywood forms, he needs room to nail down the 2x4s on each side to put the plywood to do an 8-inch wall.
And not every engineer has the job site familiarity to appreciate the the need of the concrete guy who's forming that up. So that's a tremendous value.
Right.
So
I've
from what I'm
seen-
hearing, the main consideration was the weight and just being able to know what the material weighs and add it all up. Is that?
Yeah. I believe that I was using about 30 pounds per square foot of surface area for the hemp wall itself.
And now, so that's as you're looking at the wall, the
Yeah.
square foot of that.
So you take 30 pounds per square foot of it times 20 feet of wall.
And that includes the plaster and everything that would go along with that.
Yeah. Yeah, all that data is available in the testing, so I can get all those weights off of there. And if it's 27.5 or something, I call it 30.
I remember the engineer that we had for the house we did here. It was like, I need to know what this weighs and I need to know. And so one of my first tasks was to go make a 1 cubic foot block of this stuff and then put it on a scale. And, that was very simple, crude, and effective, but it got us our numbers for calculation. And then, you just kind of err on the side of what if it's a little more, it's okay, but if it's a little bit less, you're fine because it's strong enough to handle it.
Right. And then in the data with products that have good testing and good material properties, there'll be the density, and that's pounds per cubic foot. And if you have an 8-inch thick wall, you take that number times 0.667, 8/12. And it gives you the pounds per square foot times the height is the weight.
And so a little bit of math and just calculating those on the takeoffs are necessary for being able to do the values on the engineering side of things. And then that's where the design and the interior walls. Tell us a little bit more about the selection. I know some people will use Hempcrete on the interior walls. Excellent fire break, excellent sound barrier. It is not mandatory, but it is a preference to many. Were there any engagement points on that as far as the considerations for engineering or the decision making on whether to do that or not?
You mean make the interior walls out of hempcrete? In the past, even people with light straw clay, they would make their interior walls out of that. And I personally haven't had any projects with hemp block or hempcrete interior walls. It would make for a thicker wall because you need enough material outside of your stud that it doesn't crack, that it has continuity in itself. So I think that would be a possible challenge for somebody. Now, Aaliyah's project, she had hemp walls between those wings with just doorways going into them. So
Let me share. In fact, I think maybe we should have put this at the beginning before you started talking about the plans, but let's take a look at that. Give us a talk about this, Mark. This is right after the hempcrete was put on, but the roof was not.
Right. You can see that big opening in the center portion. That's where that big 16-inch LVL is. She originally had a much bigger overhang, so we had to have a beam out there and a post. But I think in simplicity case fact, she got rid of that. On that center section, those two rectangular and that vertical window, I think that's where the loft is. So, but you can look through the window in this left section, you can see that there's a hemp wall back behind there. So that's on the interior. So that's the separation between the wings.
And she was able to do a rounded doorway also between two parts of the wings. I can't remember which one, but I've seen pictures of the finished project and those had this nice rounded doorway. That was kind of cool.
Oh, yeah. Yeah.
Anything else about this that you want to mention?
Not really. Well, typically, if somebody wants a big overhang, we just cantilever the eye joists. But you can see she also has big rake overhangs, which rake is the sloped side. And so we had to turn eye joists the other way to get them to stick out and do that overhang. Now, a word about eye joists being used in a home that somebody's aiming for perhaps extreme energy efficiency is the OSB webbing in an eye joist is so oriented that any heat that starts to thermal bridge through that gets dissipated into the insulation and never reaches the outside. We've probably all seen images of homes with a thermal camera and all the yellow vertical lines are the studs. If they were engineered studs made out of an oriented strand board like the OSB on the eye joists are, you wouldn't see those.
Speaking of heat, I want you to notice in the background on this photo, you can see these plants in the background that are kind of parched black sticks. Well, that's because a wildfire went through this area after she bought the land, but before she started building. So you can see that flame resistance was one of her reasons for picking Hempcrete on this. And you can even see, so they were recovering from a wildfire on this land. All right, shall I close this?
Yeah.
Stop sharing here.
I think that was part of Larry Lewis's reaching out to the Rabes, is because
Right.
the property had burned.
Here we go.
It does have those large logs exposed, but large
Right.
timber won't ignite. Thin stuff will. The char, but the char insulates the interior so it doesn't continue burning.
Any other projects that you want to talk about?
Let me look at some of these. Oh yeah, here's a good little one in Park County. There's the arrow. This has a clear story. That's these vertical windows up here, and we have a hand-packed hemp wall, simple floor plan. So the elevation views, he's putting metal roofing on it. So the foundation was fairly simple. We actually had a frost-protected thickened edge footing, and I'll show you that detail in a minute. Because it was a frost-protected thickened edge footing, it was basically 18 inches tall. So I could not spread out this point load because of the longer span. It was bigger, shorter span over here. So this one could spread out through that 18-inch footing. And the frost protected footing is in the code, and you only have to be 12 inches below grade. And depending on your air freezing index, which every building department lists in their design criteria, it tells you whether you need horizontal or vertical only or what. Larimer County none of it is over 1500 air freezing index from what I remember, which doesn't require any horizontal insulation typically.
And to bring up one point that's Colorado specific, we don't have a state building code, so every single county makes the rules and decides which version of the IRC they're going to adopt, IECC, all the other.
Yeah.
So it's really good for someone to be a code Sherpa for you,
Right.
if you're building in Colorado.
So the roof, he had a big long span here, so that's a good size ridge beam, 10 3/4 by 15. And then we were able to reduce it down because we had these different posts. Then the clear story sits up on top of that, and those windows have their own headers because that's all framed up on top, as you see here in the structural section. Here's the glue lam, then there's framing with headers for the windows. Then the I-joists come up, set on here, and then we blocked between the I-joists to transfer this point load down so they don't just sit strictly on the I-joists. And there's what that frost-protected footing looks like. And he's putting radiant heat, so we put foam underneath it. And we used our lead bracing. And then at the wall openings, we have a good-sized detail. I believe this is looking down on the wall because here's the studs, the planned view section. Now, the project that we talked about that had the curved roof on top, David Milburn's, here's that one. And I mean, the floor framing, we have transfer beams to pick up point loads because it was just a complicated project. There's this bay window that sticks out here. So we put in a glue lam beam here and hung the bay window on the sides of the glue lam. There's no roof load on the bay window, but we had to hold it up by itself. This is a curved top glue lam, and it's part of a portal frame. So the glue lam goes past, and then has solid code nailing. So we did have to have some plywood because this was a big opening, but they were able to pack the hemp around it. So when we do the block wall, this may be a framed portion because there's just too much going on, because this is the one converting to block. And then we were able to build curved topped walls here and then put our rafters this direction. And that's what David mentioned yesterday, is we came up with that design. So we don't have all these curved glue lambs going was his original scheme, to have curved glue lambs with short rafters between them. But why not use the I-joists the way they're designed, on a big long curve? So we have 2 curved glue lambs. There's this one out here too, at the edge of the deck.
So this is an example of how you saved the client a lot of money.
Right.
We understand. And in fact, we have a podcast with that team talking about this very thing for this very house.
So these I-joists are on an angle. So when we got to the bottom, we put in a vertical member to tie this whole roof down to the walls. Here's the portal frame, which is right from the code. So we use as many code things as we can, because I've had plans examiners tell me, I don't care if you stamp the plans, if it's not in the code, I'm not going to approve it, or from the code.
We'll talk a little bit more about the engagement with the code compliance and the municipal level, because you're known for the comment, well, if Mark's stamp is on it, then I'm okay with it. And then that didn't come from them just liking your smile. How did you establish those relationships and that engagement at the compliance level on the local municipalities that are so fond of the work that you do?
Well, on the project there in Loveland, what was her name again? I'm sorry. You said you had pictures of her. Andrea, yeah, from San Francisco. We ran into some junior plans examiners that gave us some grief. They said, well, this is a stucco system, so where's your mesh? Where's your scratch coat? Where's your stucco stuff? And I had to use some of my ASTM. That's when I joined ASTM, was for that project. I could go into the codes and the standards that they provided and insert language into my submission. And finally, I had to call the chief building official and say, okay, so doesn't understand this. So he went and looked at it and talked to him and told him, no, this is fine.
So maybe we'll do a whole nother podcast on polite persistence.
I have a pretty extensive library of alternative material form that I was able to put together for building officials. It's not all in one document. I've converted K values to our R value to come up with the heat capacity, because in the code there's a heat capacity of 6 is needed for a mass R value wall. Well, we did that with 12 inches of Hempcrete. Had a heat capacity of 6, and I had all the documentation to be able to do that. Other documentation was, I guess it was mostly all of that, converting from K value to R value, and then converting that and creating the heat capacity.
And that's the important thing to know, not only that it can be done, but how it can be done, to where as we go into this, we're going to need to translate. And it's almost like translating a language, going from those European values. And a lot of the work has been done when they're installing there. I know the straw bale community did a lot of the heavy lifting on the natural building materials, that we use a lot of their work on that straw building technology for Hempcrete. And so you mentioned having a library of just where you can draw from to where you can make that transition and translation and connect those dots to where somebody on a municipal level can go and have a good level of comfort knowing, oh, you did your homework and you connected all these things together. And then those are the things that I'm going to use to protect the citizenry and themselves from liability. And then that's any other examples of that that you saw that were ones where you connected those dots from the other materials that you gathered together?
Without digging into everything, my brain is too old and too full to find the file drawers very easily. But I wanted to share a couple of unique architectural forms that we've done. You don't need a rectangular. We already saw the Strauss house previously, and I didn't show the architectural plans, but you have that on another podcast with a curved roof. Well, this is the Cosmos Stargazing Resort down in San Luis Valley, I believe. So this part is all hemp, and then these were stargazing open domes, and over here is a little a sitting area, a netted sitting area where you can sit there and look at it. So we did all of these plans. Simple foundation system, just a thickened edge slab for most all of this. And then the structure was just eye joists for the floor and for the roof, depending on if we had a second floor or not. And then another kind of fun project. I don't believe this thing never really got off the ground, but this was going to be a hemp wall dome, like a yurt, a panel yurt with a self-supporting roof. We have another little side project called Round Foot Homes, and we've done those out of SIPs. We've done them out of frame. This client was going to use hemp walls, and all the rafters or the SIPs come together at a compression ring, which has a skylight in the center. And it's a self-supporting roof because we use straps around the corners of the roof system to keep it from squashing down. That's a couple of interesting forms that you can do as well with Hempcrete.
Yeah, I know that's one of the desired attributes is you're not bound by straight lines when you're designing things. You can have a curved wall or a dome, or you're limited by your creativity and what a structure would bear.
Mm-hmm. We have another project that we worked on that didn't come to fruition, was a produce processing facility for the Sunrise Ranch near Loveland. But this was all also hemp lime, and it had a drive-out basement. There was produce rooms, produce wash station. These walls had to have FRP on them. Now, we never got this into permit submittal, so I don't know what responses would have been, but we did this according to code.
And that would be the IBC, right? Because this would have
Yes.
been a commercial
Yep.
project. And Hempcrete is not in the IBC right now, although there are ways to sort of use the IRC to make sure that it tags the basis for the IBC.
Right.
Looks like you got a double stud configuration on it.
Well, this is the studs. Now, this is a section view of the wall. So these are the studs, but we put these 2x4s fastened to the studs with enough to have a 1-inch airspace behind the Hempcrete.
Oh, okay. That's your side view.
Where we had to have the FRP walls. And we did some of this with Jeremy Stevens in his project because some of his walls had metal wainscoting up in Steamboat Springs. So we have this airspace, and then you can put your fastening for your extra sidings, your FRPs, things like that. And the section view for this, it was pretty much typically a 2x6 wall with these horizontal 2x4s fastened to it. They had a change of ownership, and we were informed that they weren't going to continue this project, but they paid us for it. So it's sitting here.
So what's next on your outline?
We've mentioned a little bit about the code appendix. Now, in the 21 IRC that I have tabbed on my computer, they still call them Appendix AY for hemp. I've used AR for light straw clay, AS for straw bale, AU for cob, and they even have a AW for 3D printed. And I've heard people talk about trying to get a hempcrete mixture that can be extruded and then 3D printed. The interesting thing too about the development of 3D printing is they used to set up a giant frame around the house, these big giant columns and then cross beams, and then the thing can move on that. They're doing it on what we call cherry pickers now, boom lifts. They're robot controlled, and it steers them and drives them and turns them. And the arm goes here and goes there. And you don't need to set up this giant frame. You can do it just from this mobile device. Now, there's a company in Greeley who moved in here to do 3D printing, and I was pretty excited to get connected with them. Well, they're doing curb and gutter. That's pretty much all they're doing right now as they gear up. However, I talked to a fellow up in Wyoming who's got autoclave aerated concrete blocks, which are all over Europe. And he's building a big plant. He's already got one. He's going to build 2 more to start doing homes out of that material. So
that's using the technological advances in some systems translate to advantages in other systems. You just have to know how to connect the dots and think the thought.
Right. And then I've mentioned some of the projects I've worked on. We've worked on 18 hemp projects here in Colorado since 2014.
Fantastic.
Yeah. You know, we've got the resort, all the resort projects for the Cosmos community, and Gene's involved in that also. Elias project, the Strauss residence, and others that I've shown.
So what are some of the takeaways that you would advise an architect or an engineer looking to engage in this niche based on all of those projects? Any takeaway tidbits?
Well, the one thing we've learned is rather than us having to rescue somebody from an architect, we had one poor client that had 3 designs before he finally had us do it so he could afford to build it, is get involved with the engineer, either the homeowner needing just plans drawn. We're a firm. There's very few firms that the engineer does architectural plans, so we can work in that, both spaces, or get the engineer experienced in what you're going to build with involved. The guy I'm rescuing in Alma, Colorado, he, even though I believe it was the hemp block company's engineer, I don't know if he had confidence in his material or not, but he's the one that came up with that ridiculous steel system. So if you have as an architect, you have a client that comes to you, find an engineer who knows how to work with this stuff and to help advise and inform the design so it's buildable and affordable. Yeah, the Strauss house is beautiful. It's got some money involved.
What are the key components for carving out this niche? Product familiarity was one that you hit on quite a bit, and how the things go together in the different types of systems, be it hand cast, spray, block, all those things. What are some of the key, other than a career and a lifetime focused on natural building and sustainability, what were some of the key components for you on gathering that and getting that engagement?
Read the codes, read these appendices. They help guide. I developed all my details and all of that without these because they're fairly new. With the hemp one is fairly new. Just become familiar with those codes, with the complete IRC, you'll have a building official ask for something like the one did for me for stucco, where you can even go into the code or the ASTM and find a rebuttal. Well, it takes a little back knowledge and extra time.
Well, that familiarity will be a tool in the toolbox so that when those conversations happen, I'm real fond of saying you got to know how to think the thought. You have to do that. And anytime an architect or an engineer can get hands on material, I made the mistake early on. I was engaging with our design team, and it was a palm on face moment when I brought my little sample we were talking in, and then I let them tinker with it. And they're like, Ray, this is the first time I've put hands on this material. And I was like, okay, I should have done this a couple months ago. And so anytime anything can be samples made, sample walls, sample bits of material, especially through the purveyors of this type of material, are going to come up with a lot more of those education tools to where these professionals can actually hold it in their hand and then work with it. And then I love the background and the experience you've got of actually job site experience, which was so valuable on all the things that I'm doing as well.
Right. When we were in an office, my townhome up in Wellington, I would take the guys out on field trips. In fact, before we moved into the office, we went up there when it was being framed. And okay, here's the header. Here's what a trimmer is. All the various parts that they were drawing in their designs. We went to a pole barn so they could see the girts and the skirt board and how the trusses are connected and all that stuff. Quite a few of us went out to the house there in Loveland for a field trip to see it during construction. And then when there was a special open house, I was busy, so my office manager went in our stead and she represented us. So I like to get the guys out there. When I had an office, I had one whole area devoted to construction samples. Here's an I-joist. Here's a microlam. Here's a piece of hemp block. I had some hempcrete that fell out of one of Jeremy's walls, so I brought it with me. I had a piece of autoclave concrete, aerated concrete. Now they're in storage, but my stepdaughter is organizing my storage and cataloging everything. So now I know if I want to show somebody something, I can go get it and show it to them.
Many of these projects are projects that are people are very passionate about, and if you want to go have that on that job site visit, many will welcome that, if not seek it out, because one of the things that many who are building with these materials, they want others to do the same, and so they're an educator and an advocate for you as well.
Yes.
Any other things that you want people to know about? Questions that you would like people to ask you that they don't and you wish they did, or vice versa? And lastly, what are the things that you're most excited about seeing built with hemp?
I'm just happy about the houses that are being built with hemp, either hempcrete or hemp block. Like I said earlier, I'm excited to see the progression of that, especially if we can get manufacturing here more locally. I always like to know, especially on a more complicated project, who, if I'm working for the homeowner, who their builder is. I have a somewhat complicated project, and the first thing after signing it was the people with toxicity issues. The builder and architect and I had a team meeting, not even the homeowner, because the builder knew what the homeowner's concerns were, and so was able to speak for them to get that whole team involved. I've even had people that do basement finishes, basement design companies. They'll get their whole design done, then they'll bring it to me and they'll say, oh, by the way, we have to take out that steel post. Oh, sure. We'll just bring in a whole bunch of welding blankets and welding rigs and big extra steel pieces and weld to that beam. You should have called me first.
That collaboration up front is huge, and that's probably the main thing that I like to preach and teach on. And I think you've given us some really great examples of how that happens and some practical applications, things to know that help us connect the dots and think the thoughts along the way. Mark, any other last thoughts? And if not, we'll wrap up and might have some other questions for you that lead to further conversations down the road.
Well, no real. I'm very glad to be involved in this industry for all of the natural home construction that I've done. I have a job with a rammed earth client right now that I'm doing. So I like this movement. You mentioned COVID. I've done so many addition and remodel plans since COVID started. I'm working with people with what they need.
Yep, it's a good time to think the practical thoughts and execute on some good plans. And so with that, we'll wrap up here. And if
Thanks
you're
so much, Mark.
And then a final note, if you're following the instructions on getting your AIA continuing education from this podcast, there'll be instructions in the description that you can engage with us and then have that go along to you to provide those continuing education hours for your renewals. And then make sure and tune into the other broadcasts that we have that will do the same for you, as well as bring in different points of view on all the aspects of building with hemp. So with that, we'll wind down here, and thanks for joining us.
Thanks, everybody.
Thank you.